Hey, what's up, everyone? So we have got a few questions from Tech Mahindra. So it's 2025 entry question, and we'll see one by one. Okay. So in this video, we'll just find out this logic. Okay. So here the input string is nega, and then in output we have to form a triangular pattern. Okay. So logic, like as you know, from this transformation, you will know definitely like you will be using the string substring. Okay. So but the thing is like here we have one cross one. Okay, one row, and then here we have a couple of rows. Okay, total 7. Okay, so we have to transform into multiple rows. So obviously you know the component, right? So we'll go for normalize. Okay, so we'll see the design, and then we'll see the concept involved, and then mainly the logic. Okay, you have to sit and crack the logic here. Okay, so maybe in the intro time, like you can take a couple of minutes. Okay, you can take some 1 or 2 minutes, and then you can arrive at the code, but the logic here is important. Okay, so we'll just see the design now. So design, as you know, we are converting a single row into multiple rows. So normalize, and then the concepts involved. Okay, so there's not only substring. Okay, substring, string substring, and then uh, next in sequence. Basically logic. Okay, so you have to know, brainstorm. Okay, so daily brainstorm some few questions, and then you'll know the, okay, you'll get practice with the logic, and then it'll be easy for you. Okay, so so my advice is like be strong with the string functions, and then practice the logic daily. Okay, so we'll just see the logic code today. Okay, so in the normalize, so as you know, there are two functions. So length determines how many times like you have to print. Okay, so how many lines you have to print. Okay, so here you take any name. Okay, so Neha or Manoj or whatever. Okay, 4 or 5 digit. Okay, even or odd. Okay, doesn't matter. So you take a name. Okay, you take the length of this string, and then here we have 4, and then 4 is getting converted into 7. Okay, so if you take the count rows. Okay, count of the rows count, you'll get a 7. Okay, so definitely like obviously for all the names, you will get n into 2 minus 1. Okay, so n will be the total length of the string. Okay, so here we have 4, so 4 into 2. Okay, 8, 8 minus 1, 7. Okay, if you take Manoj, you will get a 9 rows. Okay, so Manoj involves a 5 total length. Okay, so total length of the Manoj will be 5, and then 5 into 2, 10, 10 minus 1, 9, 9. Okay, like that. Okay, you take any name, and then you follow this strategy. Okay, so for the length function, so length function. Okay, so for for declaring the length function skeleton, please watch the above link. Okay, so just go through my normalize playlist. You'll come to know like how to declare skeleton. Okay, so I don't have to declare skeleton like one like in each video. Okay, so I'll just straightly go to the logic. So here in the length function we have to return, okay, so length of int dot data. Okay, and you take this one minus 1. Okay, so like for Neha, the length would be 4. Okay, so 4 into 2 minus 1, so that would be 7. Okay, 7 times your normalized core function will run. Okay, core will run, and then each time you have to try to print substring of this name. Okay, so for the first time it has to take the first character, and then in the second time it has to take from go from like 1 to 2, and then 1 to 3, and then 1 to 4. Okay, so you take your okay, paper and pencil, and then find out the logic. Okay, when you sit and brainstorm yourself. Okay, so substr. Okay, you take in the data. Okay, data. So this is a logic. Okay, I'm just telling conceptually. Okay, so substr and then data for the first one. Okay, for the n nega, for the nega, like for the first time the normalize runs, it has to be 1 comma 1, and for the second time, okay, for the second time your index would be 1. For that it should be index plus 1. Okay, so basically for for a try. Okay, for taking the, okay, for split, like taking the strings character out of this name, you'll be going for substring, and then you can arrive at the conceptual idea. Okay, so it should be like this, but the thing is this, okay, this logic. Okay, so this logic will be suffice. Okay, so will satisfy up to up to nega. Okay, so up to nega. Okay, what happens after that? After that you have to reduce. Okay, you have to reverse, and then you have to print NEH, and then NE, and then N. Okay, so for that, there is some logic involved here. Okay, so the logic is simple. Okay, so here first we'll see the core function. Okay, so length function is over. We'll just go to the core function. Okay, I'll just okay, I'll just draft it right away, so that and then I'll just explain. Okay, so here in the normalize function, okay, so in the normalize, first we need the length. Okay, so we need the length of the name. Okay, so for that I'm just declaring, okay, so length equal to this one. Okay, so here for Neha you will get total length 4. Okay, so keep this one aside. Okay, keep this in comment and then we will check. Okay, so here I'm at the same time I'm going to declare a string. Okay, so temp, okay, consider temp, and then here my logic comes. Okay, so here my idea. Okay, so I'll just tell my idea. Okay, so here every time your normalize runs, okay, your normalize will run for here like 7 times. Okay, we have arrived. Okay, so total 7 times your normalized core compound will run. So here your index starts from 0 to 6. Okay, so for the total 7 times it will run from 0 to 6. Okay, for if you're new to this channel, like please refer to that normalized playlist. Okay, to understand to see different use case, and then to understand like whole idea about normalize. Okay, so here it will run from 0 to 6, and then for the first time. Okay, so my idea is that, so okay, so 0 1 2 3. Okay, so normally 1 2 3 4. Okay, so your length is 4. So my idea is, if the index, okay, if the index, okay, 0 from 6, okay, 0 to 6, if the index is less than 4, okay, I'll be applying this logic which I written. Okay, like substr, okay, data comma 1 comma index plus 1. Okay, this one is for conceptual idea for index less than length. Okay, so that would be 0 less than 4, and then 1 less than 4, and then 2 less than 4, and then 3 less than 4. Okay, for these. Okay, for these runs, okay, you'll be for this you can like this condition will be we have given this condition, and then inside this condition we can write this core idea. Okay, so I'm going to write that. Okay, so here if if index, okay, if index less than length. Okay, so for the first time your normalize runs, after the length function your index will be 0 0 less than 4, the satisfies. Okay, the rule satisfies, and then here I'm writing the core logic string substring, and then here we have in data comma 1. Okay, it has to start. Okay, so for all these rows the n is the starting letter. Okay, so here I'll be starting position. Okay, so my position is 1, always starts with 1, and then here index plus 1. Okay, so the same logic here. Okay, so here okay, so assume, okay, for the first 0th run, okay, 0, and then 1 2 3. Okay, so up to 0 to 3 your rule, okay, this rule satisfies. Okay, so for 0 it would be n. Okay, because in that, okay, your total name name will be there, and then first position, and then 0 plus 1, so 1 comma 1. Okay, so here after that 1 comma 2, and then for the 2 1 comma 3. Okay, and then for 3 1 comma 4. Okay, so we have got these entries. Okay, so we have got 1 2 3 4. Now we have to solve for this one. Okay, so we will write the else part. Okay, we'll keep it this one aside. So here, okay, so here after the else will be there. Okay, I'll just take it to the next line. Okay, else my logic. Okay, so this is an important one. Okay, so here string substring in the data taking the total name, and then I will start with the first position. Okay, for this use case, and then here, okay, so here I'll just write the code now. Okay, index minus next in sequence. Okay, so multiply, okay, 2 minus 1. Okay, that's it. So this one's a core, so see, the core idea is, okay, so if you came across this question in Tech Mahindra, like they will be expecting this idea. Okay, so these two, and then this, this if else condition. Okay, so this is important one. Okay, so now I'll just we'll just see. Okay, for the next one. Okay, for the 0 1 2 3 fine. So when a normalize runs for fourth, okay, fourth, definitely this rule will not satisfy. Okay, because here if index is 4, okay, index fourth index and then less than total length. Okay, so if you think of the logic here, okay, so for the fourth normalize run, so you have to calculate, okay, we will be calculating here the total, okay, nega, and then starting from first position. Okay, so first position will be n. Okay, and then we'll see, okay, we'll compute this one, okay, for the fourth run. Okay, so he will compute index, okay, index is 4 minus bracket, okay, action sequence, okay, when the no when the else spot, okay, when the else spot gets started, okay, the first time it runs your action sequence will be 1. Okay, so for 0 1 2 3 your else spot wouldn't have started. Okay, so we have computed with the if condition, and then for the fourth run your rule, it didn't get satisfied, and then else loop gets started, and then your action sequence gets hit, and then it will be 1 into 2 minus 1. Okay, that would be 4 minus bracket. Okay, so here 2 minus 1 1. Okay, so equal to 3. Okay, so that means your from nega 1 hyphen comma 1 comma 3. Okay, so that would be 1 comma 3. Okay, so it starts from nega and then it goes up to NEH. Okay, EH. Okay, like that. For the fifth run, same thing. Okay, your index is 5 minus action sequence. Okay, when the second time it runs, okay, your rule will not satisfy, and then second time else spot will run, and then here the action sequence would be 2, 2 into, okay, minus 1. That would be 5 minus 4 minus 1. Okay, 3 equal to 2. Okay, so that would be starts from a 1th position and ends like goes up to second position. Okay, so that would be NE. Okay, so like that for the sixth time. Okay, for the sixth time it runs, it will be N. Okay, so that's the logic. So we have printed the extra 3. Okay, NEH and NE and then N. Okay, so so this is core logic. Okay, so after this just print. Okay, so data and then 10. That's it. So that's it. So mainly like this is a core, core part for arriving this. Okay, so always like practice this. Okay, so when it's like this one comes with the practice, and then you have to think and crack the logic. Okay, so if you practice it will come, and then if you have any other questions, like comment below. So we'll see the next videos. Okay, so next videos I have the lineup. Okay, city and distance. So like many people requested that, like a few guys commented down in the video, and then recently we have got the question of filling the gaps. Okay, so this will be an interesting one. Okay, so it will be more interesting, so we'll just see the video. Okay, so the next upcoming would be city and distance, and then filling the gaps, and then after that we'll see the concepts. Okay, PDLs, and then other AWS and other things. Okay, okay, check the codes, and then please do practice. Okay, so even if I code it here, please do practice this in GD, because because even I would have I like mistakenly or I'm okay, whatever, I would have done some mistake. Okay, done some mistakes or any brackets or any lines. Okay, so like please feel free to correct that. If there's any mistake in this code, you just check it in your GD and then comment down in the video, so that others get benefited. Okay, so others will know. Okay, so they'll be like they'll know. Okay, they'll practice in that GD, and then they'll follow your advice. Okay, so that's it for today. I'll just see you guys in the next video. Okay.